Welcome to the lesson, Automotive Locksmith Overview. This lesson is a survey of the lock and key systems used by automobile manufacturers and the evolution of these systems. This lesson is brought to you by KeyCode Pro, the Security Technical Institute, the Society of Professional Locksmiths, and iSteelCars.com. I am Tom Seroogy, your instructor for this lesson. When this lesson is complete, the student will have an understanding of the various automotive lock and key systems used, including terms and definitions important to automotive locksmithing, and the evolution and differences of the various automotive columns, locks, and keys that affect the service procedures of the automotive locksmith. To complete these objectives, this course covers lock and key systems, and overview of automotive lock service. Let's start with the discussion on automotive lock and key systems. The lock and key system is the basis for most any lock service performed on an automobile. The term lock and key system is a rather broad term and includes a number of different facets of the car's physical security. From the locksmith's perspective, there are several important pieces to the lock and key system. These include system specifications, which include the dimensional characteristics of the system, like spaces and depths. Then there are non-dimensional characteristics that also help define the system. These include the key blanks, key codes, and tumbler positions. Let's cover these characteristics in a little more detail. System specifications are the dimensional characteristics of the system. This includes information like the number of cuts or spaces that the system uses and the measurements of each space, the number of depths the system uses and the measurements or drop of each depth, the location or position of the stop. The stop is the point from where the distance of the first cut on the key is measured. For automobiles, the stop may be the shoulder or the tip of the key, depending on the system. And finally, the key groove or profile that the system uses. For domestic vehicles like General Motors, Ford, and Chrysler, a predominant number of the locks and keys are produced by StratTech. Unlike the systems from many other manufacturers, StratTech identifies and labels the groove or profile with each system they create and then includes that number in their system specifications. By including the groove in the system specifications, identifying what keys are used in the system is fairly easy. Regardless of any differences between a group of keys, like the size of the bow or the length of the blade, a key can be identified as belonging to a specific system by simply identifying what groove or profile it uses. Unfortunately, we find that most import automotive system specifications do not identify a groove within their system. Now, while each lock and key system does in fact use a specific groove or profile, the manufacturers of these systems typically do not give them a specific label or number and include it in their system specifications. As such, the only way to connect a specific key to a specific key system is by the part number of the key blank and the code series used to cut that key. Now, the next slide will further explain the groove concept. Regardless of the manufacturer, every lock and key system includes keys. And like all other components, the key is given specific measurements and dimensions so that the key can be manufactured. The blade of the key has mill runs or ridges and grooves that create a specific shape or profile. These ridges and grooves are given specific measurements and dimensions that define the shape or profile of the key for that system. Then, for as long as the system is used, these measurements and dimensions for the profile of the key remain the same. On lock and key systems produced by StratTech, the dimensions and measurements for the profile of the key are called the groove. To make it easy to identify, StratTech assigns the groove a specific number or letter and includes it in the system specifications. For example, the General Motors 10-cut system introduced in 1994 includes a master key groove number 75 and a valet key groove number 88. So why assign a single letter or number to a groove? Well, actually, it's quite simple. For any given system, the groove or grooves do not change, and all keys that are to work in that system must have the same measurements and dimensions for their profile or groove. In fact, if one were to look deeply into a lock and key system, the key dimensions for the profile or groove would be found. Confusion begins, however, in that over the lifetime of a lock and key system, a dozen or more key blanks of varying blade lengths and or bow sizes and shapes may be created for working the locks on that particular key system. With so many keys going to the same system, if a groove is not identified as part of that system, then the only way to identify the keys in the system are to either compare the measurements and dimensions of the key blade against the measurements and dimensions required by the system, or by listing and including all the part number of all the keys that go to the system. So, for the sake of keeping things simple, lock and key systems produced by StratTech identify keys by their groove, and all keys having the same groove belong to the same system. Now let's look at some of the non-dimensional characteristics of a lock and key system. We'll begin by looking at information related to key blanks. This information includes the key groove or profile, which is not only an attribute of the system specifications that we mentioned previously, but also of the key itself. The keys will also follow one of two hierarchies. These hierarchies include a primary-secondary key system or a master-valet key system. More on the key hierarchy is covered in the following slides. The number of sides used by the key is also an important attribute of the key blank. While more cars are coming with high security and specially designed keys, the most common automotive keys are either single-sided or double-sided. For keys that are double-sided, they may also be either convenience keys or true double-sided keys. More on the double-sided keys is covered in the following slides. For now, let's take a more detailed look at the key blank hierarchy, that is, primary-secondary versus master-valet. The manufacturers of early model vehicles, especially the domestic manufacturers, design locks and keys based on a primary and secondary concept. A primary-secondary key system is one in which two or more keys are used to operate the different locks on the vehicle. One key, commonly called the primary key, is used to operate the ignition lock and sometimes the door locks. A second key, called the secondary key, is used to operate the door locks, trunk lock, and the glove box lock. These keys do not interchange, and a primary key cannot be used to operate a lock built for the secondary key, and the secondary key cannot be used to operate a lock built for the primary key. In short, the car always needs two or more keys to operate all of its locks. Late model vehicles and a majority of early model imports, however, typically use a master-valet key system. In a master-valet key system, one key, called the master key, is capable of operating all the locks on the vehicle. A second key, called the valet key, is able to operate the ignition and door locks only. It is not capable of operating the glove box or the trunk lock. The logic behind a master valet key system is actually fairly simple. The driver or owner holds and maintains custody of the master key, which is capable of operating all of the locks on the vehicle. Should the vehicle be brought in for service or to a hotel, airport, or other location that has valet parking, the valet key is surrendered to the parking attendant. This key allows the car to be entered and parked. but prevents anyone from entering the trunk or glove box. Next, we cover the concept of a double-sided convenience key. Double-sided keys are not new to automobile manufacturers. Ford has been using double-sided keys since about 1966. Chrysler began about 1989, and GM started about 1994. Most import vehicles have been using them long before these times. As double-sided keys, some are classified as convenience keys. This means that while the key is cut on two different sides, the cuts are identical. This allows the key to be inserted into a lock without considering which side is up and which side is down. Because they can be inserted into a lock regardless of which side is up or down, they are called convenience keys. In other words, they are cut the same on both sides for the convenience of the customer. A true double-sided key, on the other hand, has different cuts on each side and can only be inserted into a lock in one direction. Older Volkswagen keys are examples of a true double-sided key. Today, most all domestic and import automobile manufacturers use double-sided convenience keys for their cars. Linked to the key blanks, the code series lists all usable key biddings for a system. Key codes may be direct. These are codes whose numbers or letters actually represent the spaces and depths of each cut on the key. While direct codes are common with residential and commercial keying systems, a few older automotive lock and key systems also use direct codes. Older Renault cars, for example, used Neiman-produced pin tumbler ignition locks where the key code was a series of letters which represented the depth and space of each cut on the key. Today, however, most all automotive lock and key systems use blind codes. That is, the key code is a number, letter, or combination of numbers and letters that have no direct relationship to the spaces or depths on the key. Instead, the key code is linked to a specific and unique key bidding that is part of a list of all possible biddings for the system. Finally, another characteristic of a lock and key system is the tumbler positions used by the locks and keys. Typically presented in the form of a tumbler position chart, the tumbler positions show what spaces are used by each lock on a vehicle. This tumbler position chart, for example, shows that the ignition for cars using the Ford 8-cut lock and key system have tumblers for positions or spaces 2 through 8. Again, tumbler positions is not a dimensional specification, but rather a trait of the locks and keys being used on a car. Furthermore, unlike most dimensional characteristics, tumbler positions are fluid, often changing not only with every new model year, but also with each individual model. For the locksmith, knowing the tumbler positions of a lock are critical for generating a new key or keying a replacement lock to fit an existing key. When it comes to tumbler positions, a lock and key system may be either partitioned or non-partitioned. A partition system is one in which the different locks of the vehicle only use a part of the cuts or spaces on a key. On the 1996 Ford 8-cut system, for example, referring to the tumbler position chart on the previous slide, the ignition lock has tumblers for cuts or spaces 2 through 8 of the key blank. In other words, there are no tumblers for space number 1 or cut of the key. The door locks for most Ford vehicles have tumblers for spaces 1 through 6 on the key, while the glove box uses spaces 6 through 8. A non-partition system is one where all the locks use all of the cuts or spaces on the key. Today, most all domestic and import automobile manufacturers use partition systems. Lock and key information is critical to the automotive locksmith. The challenge, however, is knowing where such information can be found or obtained. The following are good sources for this information. Probably the best provider for lock and key system information, especially for key code and key blank information, are either the manufacturers of the cars or the company that produces the original equipment locks and keys for the manufacturer. Strattec is a good example of an original equipment lock and key manufacturer that provides all the lock and key system information necessary to the locksmith. Another source for information comes from aftermarket key code books and software. Today, most code books are being replaced by easier-to-use key code software. Blackhawk and Instacode software represent some of the best key code software currently available. Finally, aftermarket technical manuals like AutoSmart and FastFacts provide much of the lock and key system information necessary for the automotive locksmith. In this next section, we'll discuss several important concepts of automotive lock service. The topics for this section include an overview of the types of columns one will find, the various types and styles of ignition locks, and the various types and styles of door and trunk lock types. Let's get started with the review of the column types. Over the last 3 decades, major differences existed between domestic and import columns. Once influenced by factors unique to their origins, the evolution of domestic and import column engineering approaches has actually resulted in column, lock, and key designs that are almost indistinguishable between the different manufacturers. Prior to the late 1970s and early 1980s, columns of domestic vehicles shared a unique design approach that was very much different than that of their import counterparts and competition. As the global market began to form and mature, however, both domestic and import manufacturers started adopting engineering approaches that were very similar. The result is that by 2000, most all columns, domestic and import, were virtually the same. Still, the beginning years of automobiles saw 2 distinct column types that even today the locksmith must know how to service. These column types include the integrated column and the modular column. Let's look at their differences in a little more detail. Introduced in 1969, the GM Saginaw column stands as one of the most prolific columns of its type. With an increased focus on the security of the vehicle, the Saginaw column moved the ignition lock from the dash to the column and introduced a steering wheel lock. With the ignition lock now located in the column, it was now used to control both the ignition switch's on, start, and off functions, as well as engaging and disengaging the steering wheel lock. This consolidation into the column of all the components used for security created what is called an integrated column. In short, the column itself is the container or housing for the ignition lock, steering wheel lock, as well as other components related to steering, shifting, and turn signals. Although constantly evolving, this column type was used by GM up through 2002. The unique characteristic of the integrated column is that in order to service the ignition lock, it was necessary to disassemble most, if not all, of the components in the column, including those related to the turn signal, the steering shaft, the steering wheel lock, and on later vehicles, the airbag system. Both Ford and Chrysler either used versions of this column or built their own based on the integrated design. While during the early years domestic manufacturers focused on the integrated column design, in an effort to compete in a global market, the import manufacturers pursued faster, easier ways to both build and service the cars they produce. This involved an engineering approach that focused on separating components based on their function, or modularization. This approach in building was reflected in their column design and the introduction of modular columns. Starting around the mid-1980s with the proliferation of globalization, GM and other domestic manufacturers also moved toward engineering methods that produced cars that were easier to repair and more cost-effective to produce. The result was that they too started building cars and columns based on black box engineering or the modular concept. The ignition lock, for example, while it still controlled the on, start, and off functions, as well as the steering wheel lock function, was now housed in a separate unit that was fastened to the column. Even the ignition lock cylinder became a single, easily serviced unit. In short, the move towards modularization resulted in a column whose components are easier to produce and service. Since then, modular columns have become the standard for all manufacturers. The move towards black box engineering or modularization resulted not only in modular columns, but also in changes to the parts connected to the column. Let's look at how this approach affected the design and serviceability of the ignition locks. Following the modular approach, import ignition assemblies were separate units attached to the column, yet they still control both the ignition's on, off, and start functions as well as the steering wheel lock function. Although there are other methods, many of these assemblies are held to the column using a strap and breakaway bolts. Here's another example of an ignition assembly that is fastened to the column through the use of a metal strap and breakaway bolts. On many cars, the ignition appears to be part of the dash. However, once the left or driver's side hush panel is lowered, it is easy to see that the ignition assembly is actually mounted to the column and also fastened using breakaway bolts. After removing the ignition assembly from the column, it is easier to see how the single unit controls all of the separate functions. The steering wheel lock function is controlled by the steering wheel lock bolt and its related components. The on, off, and start functions are controlled by the ignition rotary switch. And all of these functions are controlled by the ignition cylinder. Yet they are all contained in a single housing or assembly that is attached to the column. Although there are times where it is necessary to remove an entire ignition assembly, for the most part, it is the ignition cylinder that is the focus of the locksmith's attention. One of the benefits of modular design is that for many cars, even the cylinder is designed to be removed from the ignition housing and serviced or replaced. This makes servicing these locks much easier than those of the integrated column. Still, for some ignition assembly types, although they are modular, the cylinder is held in place using a means that is slightly more permanent. However, in the hands of a properly trained technician, even these can be removed from the housing and either serviced or replaced. Let's examine the different methods that manufacturers have used for retaining the cylinder in their ignition lock assemblies. Although there are more, a majority of ignition lock cylinders are retained by either an active retainer, roll pins, or it is a sealed or concealed retainer. Of the active retainers, there are two basic types. Type 1, where in order to remove the ignition cylinder is turned to the on or accessory position, and then the retainer is accessed through a hole on the ignition housing and the retainer button is depressed using a scratch-awl or similar tool. This type of retainer is common among Japanese and Asian-produced vehicles like Toyota, Lexus, Scion, Suzuki, Hyundai, and others. Then there is the Type 2. This retainer type is very similar to the Type 1, except that there is no retainer access hole in the ignition housing. Instead, the access hole is part of the ignition lock face. To access the retainer, the ignition must be rotated to the on or run position. This position aligns the access hole on the face of the lock with the retainer located near the back of the lock. Once the lock is rotated properly, a probe is inserted into the access hole and the retainer is pulled down or depressed, allowing the cylinder to be removed from the ignition housing. This type of retainer is very common on German vehicles like Mercedes, BMW, Volkswagen, and Audi. But regardless as to whether it is a Type 1 or a Type 2 retainer type, the ignition lock must be rotated to the on, accessory, or run position before the retainer can be depressed. When it comes to servicing, the more challenging locks are those whose cylinders are held in place using roll pins. Although their removal methods are identical, there are two distinct types of roll pins that are commonly used. First are those that use solid roll pins. As the name implies, the roll pin is solid and usually has one or both ends chamfered or beveled. The second type of roll pin is the hollow roll pin. This pin is usually made of rolled spring steel. Although not common today, a few manufacturers had ignition cylinders that were either concealed or sealed within the ignition housing. The cylinder retainers of early Volkswagen and Audi were made from bands of spring steel. The cylinder was slid into the cylinder sleeve where the retainer snapped into a groove that was hidden or concealed inside the sleeve. There were two methods for removing these cylinders. First, a feeler gauge could be slid between the cylinder and the cylinder sleeve in an attempt to force the retainer down. This process was very similar to lloyding the latch of a doorknob on a locked door. The second, more popular option was to measure back the appropriate distance on the cylinder sleeve to a location directly above the retainer. Then a scratch-awl was used to punch through the rather thin surface material and depress the retainer. Early Mazda, on the other hand, really didn't use a retainer. Instead, the cylinder and other components were installed from the back of the housing. A metal plate was then staked into place, forming a sealed unit. Disassembly of this unit, as we will see later, requires removal of this plate. Now let's cover some of the important concepts related to servicing door and trunk locks. While door and trunk locks vary with the number of cars produced, most can be classified based on the following criteria. The lock's location on the car. The functions the lock is designed to perform. The type of retainer used to hold the lock in place, and the type of face cap the lock uses. Let's cover each in more detail. The first criteria to consider is the mounting location of the lock. There are really only two possible mounting locations for door and deck or trunk locks. A door lock will be mounted either on the door but separate from the door handle, or as part of the door handle. Likewise, the deck or trunk lock will be mounted either to the deck or trunk lid or on the body, including being integrated into various trim components or the taillight section. Interior locks are also important when servicing the vehicle. These locks include the glove box, the center console stowage box, an airbag shutoff switch, and on cars where the rear seat folds down, the rear seat back release locks, travel and other stowage compartments often found in trucks, SUVs, or in cars with hatches. Then there are locks for the interior gas lid release and the tailgate or trunk release. Door and trunk locks can also be classified by their operation. These include standard locks that are simply used to lock and unlock the door or trunk and have no secondary functions. Then there are active locks. These are locks that include secondary operations or features like buttons that need to be depressed. This is the most common on the trunk lock. Then there are locks that include a deadlocking feature, most notably those used on BMW. Finally, some locks include a clutch function, a feature that is included to help prevent the lock from being picked or force rotated. Door and trunk locks are held in place using a number of different fasteners or methods. The most common retainers include U or horse-shaped metal clips. These were once the most common type of door and trunk lock fasteners. As car designs changed and the door locks began to be incorporated in the door handles, screws, bolts, and nuts became a common fastener. The trunk and hatch door locks on early model Chrysler vehicles were held in place by a large nut that threaded directly over the lock case. On later model vehicles, manufacturers like Volkswagen, Audi, Mercedes, Toyota, and Lexus used set screws to fasten their locks to the door. Less common are locks held in place using retaining tabs. The door locks on early model General Motors trucks had a piece of spring steel swedged or staked to their side. This piece served as a locking tab for the lock that, once inserted into its pocket or sleeve on the door handle, held the lock in place. To release the handle, the lock had to be removed and the lock's retaining tab had to be depressed through a small hole located on the side of the lock's pocket. Wire clips are probably the most common type of retainer for locks that are mounted to the handle. Finally, used on interior locks, some locks are retained using friction fit components. This retaining method was common on interior gas and trunk release locks for Honda and Acura vehicles. Finally, door and trunk locks can be separated or classified by the type of face cap they use. Used on door and trunk lid mounted locks, the standard face cap was once the most common style of face cap used by door locks. As the door locks were moved to the door handle or integrated into the trunk or taillight trim, locks with snap-on or no caps became more common. While not necessarily a defining characteristic or classification, there are two basic types of shutter units used on door, trunk, and interior locks. The shutter unit is the small spring-loaded door on the face of the lock used to keep dust, rain, snow, and other environmental elements from entering the lock. Used most commonly on import vehicles are shutter units that are separated into their components and must be assembled along with the rest of the lock. These shutter units are typically broken down into three components, which include the shutter gate or door, the post, which serves as a hinge or pivot, and the spring, which is used to keep the shutter unit closed when a key is not inserted in the lock. These components are usually found in service kits offered by some of the aftermarket lock and key manufacturers. Finally, fully assembled shutter units are also common and are typical of cars produced by the domestic manufacturers. Congratulations on completing Automotive Locksmith Overview. Please proceed to the quiz for this lesson.